So we already finished with the rigid body and the animation, and we already can switch on off the animation, okay? And so we are actually going to use code to achieve that because we already got this our project. I think we got a script file and we got move player movement. Okay, so if you double click that, you will just get this editor. I'm using JetBrains Spider, and we already can get users input by got the input system up and running. So what I'm going to do is to actually get this movements of our player. So the first step, of course, is get a hold of rigid body, because you need to using rigid body to control the player. So of course you need to declare that first. We are going to make it here. Okay, so let me get the rigid body. It's 2D environment, so that will be our player. Our player's rigid body. So rigid body 2D. Yeah, we don't need rigid body 2D. Just a player rigid body will be fine. And then we grab this player rigid body to get that. So let's get that from the start of this function. So player rigid body equals to, we can use get components to get hold of the rigid body 2D. So let me just say rigid body 2D, and yeah, we just get hold of that. And yeah, I think I'm going to use this automatic completion to get that. So I think we can actually adding a walking function. I think maybe just on update. So every frame you going to execute that as long as you got a input. Okay, so what I'm going to do is to walk here, and right now it's will give you a sort of error because you haven't write that yet. So I'm going to say void and walk. Okay, and the compiler is so smart, which is to get me player rigid body or sort of thing, but let's just do it myself. Okay, so what I'm going to do is to remember we got this player rigid body, we haven't used it yet. So what I'm going to do, player rigid body velocity, yeah, I think it's pretty smart, velocity, and that will be our remember we sort of grab users inputs. Okay, so move inputs, that will be our users move inputs. Right now it will be just fine, and it will give you a sort of error bug, but yeah, let's just try this out, because I want you guys see step by step how to change that. Okay, so yeah, so let's play this game, and yeah, pretty strange. It's just flow in the air, and we can up and down, left and right. Okay, so pretty interesting, huh? We can, and let me just switch on the animation. Okay, so you can see this, something like that. Okay, so yeah, running forward, something like that, and you can see the colliders working. So yeah, it's pretty good. But yeah, the bug is obviously you can't move up and down, and it's a little bit weird unless you are in a sort of a space environment, or this is pretty like the in a space environment, or in under the water. You still get gravity working, but not as much as you thought, and it's a little bit sticky, and yeah, and of course you can swim up and down. Okay, so this is like underwater. Okay, but clearly that's not what we want, so we are going to yeah, make a little bit modification of our code. So let's solve that. Let's go back to coding. First, I'm going to initialize a serialized field. So it sort of act as a multiplier because the horizontal speed is definitely too slow. So I'm going to say serialized field, and that will be a float, and that will be our move speed. I think this speed multiplier. Yeah, let me just use move speed because I think a lot of people doing that. So the artificial intelligence, suggest me doing that. So I think it's pretty good. So move speed, I can use this as a multiplier. So every time I use the x-axis, I can say it's a multiplying move speed. So as long as we got this movement speed sort of multiplier, we're going to copy that because we're going to dealing with the bad boy down below here. Okay, so the move input definitely does not do the work because we need to specify sort of detail of it rather than use the default user inputs. So what I'm going to do is to instead of use these move inputs, I'm going to make a new velocity. It's just a vector 2, okay, because you're going to using a vector 2 here, and I'm going to say new vector 2, and remember we got move input, okay, so we got move inputs, and add the x, I think it is x code, just x to move speed, pretty good. So essentially the compiler just show us the move inputs at the x-axis multiply move speed, which will be initialized at 5f, and the player rigid body velocity y, which means that at the y-axis the velocity will not change, will just stick to the gravity. Okay, so just 9.8 gravitational pull down below. Okay, so I think that's looks pretty good, and as you guys can see, that's the reason why I use the Jetbird Rider. Because I want to use Copilot, it will greatly improve the working process. So there's sort of a symbiosis of man and artificial intelligence. Okay, so let's get it down, and it will just fall like before. Okay, so we get this left and right movement. I think this looks pretty good. Left and right movement. Okay, I think that's do the work, but never trigger the we can't move up and down, which is good. Okay, but we can't jump, and there is no animation. So I'm going to add sort of animation, and I think maybe change the tile as well, because right now the tile is definitely not enough for me to move around. So maybe let's just erase all these fences, okay, and zoom it out. Let's get the background a little bit bigger, okay, so let's scale this up. Okay, and let's paint more, maybe something like that. Okay, so something like that. Okay, and the rest we can just fill this with sort of a dirt-like material. Okay. It doesn't really matter which kind of material that you use. You sort of can, you can also use the procedure to generate that, but let's just not worry too much about that. As I already discussed, that you can use sort of a rule that fill what is in between. Right now, I'm just live with something like this. Okay. Okay, so we can actually move, but obviously we need the camera to follow along. So but we get a lot of space to walk around. So I think this looks pretty good. And yeah, if you look at our project, you'll find a weird thing is that when I want to go backwards, okay, our player, yeah, just just move backwards without actually flip the side. So what I'm trying to do is to flip that. So if I add a minus, you would just flip. Oh, sorry, this is the camera. You don't want the camera to change. Let me get this player here, and if I add a minus, we just flip. Okay, so what I'm going to do is to add a function that can flip that according to the inputs. Okay, so let me double click that. So every time that you update, I'm not going to just walk, but also I'm going to flip our player. And right now we haven't write that yet, so let's write that. Let's got the void, and here, sorry, let's got a void and flip player. Yeah, I think the compiler just got that, but I have to check that first. So move input x is bigger than 1, transform local scale vector 3. I think is a little bit dodgy because yeah, might not be the case because this is vector 3 clearly not good enough. So maybe just move alternative. So yeah, whether you got the next or not. Context section. Yeah. Maybe just give this compiler a little bit of hint. Yeah, let's just give it a little bit of hint. I'm going to use a boolean. Yeah, player has horizontal speed, mass, and yeah, I think that's pretty good. So basically, this means that if the player got a horizontal speed, which means that we got positive or negative, we use the mass app to get a hang of that absolute value, and we grab the user's original body's velocity, x-axis velocity, so x-axis velocity, as long as the is bigger than the hurdle. This is a representation of 0 because in programming the 0 is not actually 0, it's sort of like 0.1, something like that. This will be a nearest representation of 0. So yeah, once you got this boolean value, and if this boolean is true, and then we will have a player horizontal speed. Okay, and the Sun compiler just automatically generate that, and if this is true, I'm going to carry out this code transform local scale vector 3 new implicit conversion to vector form. I don't think we need to change that to vector 3. Okay, yeah, but it just automatically transform that. Yeah, so let's look at here, new vector 2 mass app. Yeah, this is like a hint, so we don't need to worry about that. Yeah, x mass app sign. Okay, so we get a sign. So whether it's 0.1 is, as long as it's positive, it will just give a sign of 1. Okay, and then the negative -1. So we can just flip the side of it, and y-axis just 1f. Yeah, I think that's pretty good. So I'm going to go with that and see whether it will work or not. So let's go back to Unity, and I think yeah, the interesting about Copilot is that it automatically generates the code, and or you just need to revise that and to test that. So it really help to streamline your process. Okay, so let's pretend that is the walking animation enabled. So Okay, I think that's pretty good. And go left and right. Okay, that's pretty good. Then I think maybe I need to add a transition from this idle to walking, because we don't want just manually switches the boolean on and off. So we're going to use a condition statements to do that maybe, and then to automatically change the state. And right now I can't jump, so if there is some hurdle here, we can't jump. So yeah, let's add the jumping animation. Okay.